Okay, Chapter 4, Lesson 3, Solving Systems of Linear Equations in Word Problems. Thus far, we have solved word problems by writing one variable equations and solving. Some of these problems can be solved by writing a system of linear equations and then using our graphing, substitution, and or elimination. First example. A first number is 4 less than a second number, and I need to write that into an equation. A first number is, so x equals 4 less than the second number. So I'm going to take the second number minus 4. Second equation, 4 times the first number, so 4x is equals 6 more than, which goes on the end, twice the second, so 2y. Find the numbers. This one is best solved by substitution. So I'm going to circle and sub. So I'm going to rewrite the second equation as 4 times y minus 4 equals 2y plus 6. So 4y minus 16 equals 2y plus 6. 2y minus 16 equals 6. 2y equals 22. And y equals 11. Take that and sub it back into the first equation. So x equals 11 minus 4. So x is 7. So my two answers are 7 and 11. Example 2. A first number is 7 greater than a second. So x is y plus 7. Twice the first number, so 2x, is 4 more, that goes to the end, 3 times the second. So again, this one is great setup for substitution. So I'm going to rewrite the second equation as 2 parenthesis y plus 7 equals 3y plus 4. 2y plus 14 equals 3y plus 4. 14 equals y plus 4, and y is 10. Sub that back into the first equation. So x equals 10 plus 7. So x is 17. Two cars leave Indianapolis. One is traveling east and the other is traveling west. After 3 hours, they are 297 miles apart. If one car is traveling 5 miles per hour faster than the other, what is the speed of each? So because we're talking about speed and distance and time, we have to remember our equation that d equals r times t. Distance equals rate times time. So I'm going to need the rate and the time for each of my cars. So for car 1, my rate is 5 miles per hour faster than the other. So for car 1, my rate is the other car, which I don't know, so I'm going to put x, and 5 miles per hour faster, so plus 5. And times my time, which is 3. Car 2, however, is just rate. It is just x, we said, and its time is also times 3. Now, we know that when these cars are traveling, their total distance apart is going to be 297. So this one, I'm going to do, instead of car 1, I'm going to write 3x plus 15, because that's distributive property. And for car 2, I'm going to put plus 3x. And then for the total, I'm going to put equals 297 miles. So combining like terms will give me 6x plus 15 equals 297. 297 minus 15 is 282. So 6x equals 282. Divide 282 by 6. And the first car, or car 2, car 2's rate is 47 miles per hour. And I know that car 1 is 5 miles per hour faster. So that would make car 1 52 miles per hour. Lynn Pike is a pharmacist. She needs 70 liters of a 50% alcohol solution. She has available a 30% alcohol solution and an 80% alcohol solution. How many liters of each solution should she mix to obtain 70 liters of a 50% alcohol solution? So we have two things going on here. We have our liters and we have our percentages. So basically we have two bottles here, and there's some amount in here and there's another amount in here, and we don't know what they are. But we know that when we mix the two amounts plus Y, we're going to get a total of 70 total liters. We also know that the percentage of X we have is 30%. So 30% in that one. And we know the percentage in the Y container is 80%. And we know that, and we need a total of 50%. Now, a lot of people's mistake is they just leave this set equal to 0.50. But if we look at our equation, for the first one, I took my percent times what was inside. For the second one, I took my percent times what's inside. And so for the last one, I need to take my percent times what's inside, which is going to be 70. Now this one is set up for elimination. I'm going to go ahead and get rid of the x's here. So I'm going to time this top equation by negative 0.30. So the top equation becomes negative 0.30x minus 0.30y equals negative 21. And the bottom equation is going to stay 0.30x plus 0.80y equals 35. So these will cross out, whoops, and I'll be left with 0.50y equals 14. So divide by 0.50 and y equals 28 liters. So in this container right here, I know there's 28 liters. I'm going to sub that back into the very first equation for y. So the very first equation is going to become x plus 28 equals 70. So x would equal 42. So I know that in the x container, there's 42 liters. In 2007, the French train Atmosphere became the fastest rail train in the world. It broke the previous record set by the Atlantic in 1990. Soon the Atmosphere and the Atlantic left the same station, one headed west and the other headed east. After 2 hours, they were a total of 2150 kilometers apart. If the Atmosphere is 75 kilometers faster than the Atlantic, what is the speed of each? So again, we're going back to our distance equals rate times time equation. So for the Atmosphere, it's 70 kilometers faster than the Atlantic. I'm going to put AT for, I guess it doesn't work for Atmosphere. So I don't know the rate of the Atlantic, but I know that the Atmosphere is 70 kilometers faster. And the time for each was after 2 hours. For the Atlantic, I know that its speed is just x, and that was also 2 hours. Now, since one's traveling this way and the other's traveling this way, and I know that their total is 2150, I'm going to add 2x plus 150, which is the distributive of the Atmosphere, plus 2x, which is the Atlantic, to total equal 2150. So that would give me 4x plus 150 equals 2150. So 4x equals 2,000. And so x, the speed of the Atlantic, is 500 kilometers per hour. And I know that the Atmosphere is 75 miles per hour faster than that. So the Atmosphere would be 575 kilometers per hour. A pharmacist needs a solution, a 500 milliliter solution of 20%, but only has 5% and 25% available. So we know we have this 5%. We don't know how much is in here. And then we have a 25% solution, and we don't know how much is in here. And we know that the total needs to be 20%, and we only want 500 milliliters. So first we're going to do our total milliliters equation. So X plus Y needs to equal 500. And then we're going to do our percentages. So 0.05X plus 0.25Y equals 0.20 times 500. So the top equation is going to become X plus Y equals 500. And the bottom one, oops, I forgot to multiply that. I'm going to multiply it by negative 0.05 minus 0.05Y equals 0.05 times 500 negative 25. And then my bottom equation will stay as 0.05x plus 0.25y equals 0.20 times 500, which is 100. So that would give me 0.20y equals 75. So 0.75 divided by 0.20 is 375 in the y, milliliters. And I know that the total is 500. So that would leave me with 125 milliliters in the other.